Hello and welcome back. Today we're going to look at the law of cosines. So the law of cosines is a little trickier than the law of sines, and we want to make sure we use law of cosines when we're given three sides or two sides and include angle, because you're not able to use law of sines right away until you figure out those other sides and angles. So if we're given a triangle ABC, and here we put it on a coordinate plane, so we have A is at the origin, B has a value or coordinate of C comma 0, and we don't know the value for or the coordinate for C, so we just put X comma Y. So for this one, if I wanted to figure out what the value would be for A, I could use right triangles, right? I could use a distance formula to figure out from B to C. So I know that for A, just using the distance formula, well, I can subtract X minus C, then square that. Those are two coordinates for X. And then we could add Y minus 0 squared, just using the distance formula. So for looking at this right triangle, we first have to figure out what's our X and Y. So if I was going to find X, I would use cosine of A. It's right here. So cosine of A, so we know that the adjacent side is X. And looking at this triangle here, right triangle, just regular little trig, and our hypotenuse is B. So that means that the cosine of A times B, or B cosine A, is the value for X. If I wanted to find the value for Y, well, I use the same triangle here, but again, we're looking for Y, which is the opposite side of A, so we'll use sine. So that's Y over B. So Y will equal B times the sine of A. And now we can substitute those values into our distance formula. So we know that A equals, I'm just make some room here, B cosine A minus C squared, and our Y was B sine A, or B times sine A. And just minus 0, so we'll just square that. All right, so let's just simplify this. I'm first going to square both sides, just get rid of this radical, and then we can distribute or FOIL, right? So this will be B squared cosine squared A minus 2BC cosine A plus C squared plus B squared sine squared A. If I could fit it in here, sorry. Get some room here. I have A already there, but I'll just write on top of it. Okay, so that's sine squared A. And now we could actually group two of the terms. So I see that we have B cosine squared and B squared sine squared. So I'm going to rewrite it so that we have B squared out in front, and I'm going to factor out sine squared. I'm factoring out the B squared, so we're left with sine squared plus cosine squared. I'll put the C squared here, minus 2BC cosine A, a little line, and we know that we can use a Pythagorean identity, so that would equal 1. So if A squared equals B squared plus C squared minus 2BC cosine A. So that's finding the value, or the square of the side A, using the distance formula. And you can see right away that that is the first formula here for law of cosines. Now we can rewrite them to solve for the angle. So if I was going to solve for this angle, I would just subtract B squared, subtract, C squared, then you have to find the inverse. But essentially you want to isolate that cosine A. And so you can rewrite that as cosine A would equal to B squared minus C, B squared plus C squared minus A squared over 2BC. So we can find the sides and the angles using law of cosines. All right, let's go to a practice problem. So for this one, we have the sides are 6, 8, and 12. And just as a review, you want to first see you can see what kind of triangle you're going to have. So we can always say, what's the relationship of A squared plus B squared compared to C squared? So that's going to be 36 plus 64, 144. So that's 100. So 100 is less than 144. So we know that this will be an obtuse triangle. Remember when the c squared is bigger than the sum, we'll have an obtuse triangle from geometry. Now, another thing you want to make sure as well when you're giving the sides is if it does in fact make a triangle. And so remember, we know that the side has to be less than the sum of the other two sides, but greater than the difference. So that's another with the triangle inequalities from geometry. Okay, so if we're given three sides, well, we need to figure out one of the angles. So we might as well start with cosine of A. So cosine of A is going to equal 8 squared b squared plus c squared, which is 12 squared, minus 6 squared over 2bc, which is 8 times 12. And it's really helpful to have these formulas down. And then you just find the inverse of that cosine. So that'll be 26.38. All right, so go ahead and practice using the law of cosines to find the other two angles. And we'll double check. All right, so here's the work for finding angles B and angle C. Again, they're approximately, but you can tell right away the side C is going to be opposite of the biggest angle, angle C, which is obtuse 117.28. All right, the second instance where we need to use law of cosines is when we have an angle, the two sides, and its included angle. So I'm going to draw this out, but I want you to pause the video again to make sure you can use the law of cosines. So there's 16, here's 12. So we're missing angles B and C and side A. All right, so let's check our answers. So again, we know that A is pretty much where we need to start off with. So that's going to be b squared plus c squared, which is 12 squared, minus 2bc times cosine of A. So we can figure that out pretty quickly. And so take the square root and it'll be approximately 18.26. Now, if we wanted to find the angle for B, well, we can use cosine, law of cosines as well. So cosine of B, just for practice, well, that's going to be a squared, 18.26 squared, plus c squared, minus b squared over 2ac. And so this will be about, I'll put this as approximately, 59.65. And then to find the third angle, angle C, you can just subtract those values from 180. So angle C will be about 70.35 degrees. All right, so again, for all of these values, we are approximating, but using the law of cosines, you have to use it when you have side, 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 or side, angle, side. Okay, let's look at a couple word problems. All right, so for those people that love baseball, we have a batter here. Again, people that don't know about baseball, the batter starts at home plate here. And this batter, he or she, is going to hit the ball to the center fielder. And usually the center fielder is in the middle of the outfield. Okay, so we're going to assume that that center fielder is in the middle of the outfield there, because usually good positioning, we have the second base and short stops right there. So usually they're right there behind second base. Okay, so the center fielder is going to throw the ball to third base, and third base is over here. And we want to figure out what's going to be the distance that the center fielder threw the ball. So we do know one of the angles. We know that this infield is like a square. So this angle right here would be half of 90, which is 45. We are also given that the distance between the bases is 60 feet. So if we're going to find this distance, well, we could use law of cosines. So the d squared would be equal to 240, let me write that down because we're given that distance, 240 squared plus 60 squared minus 240, 60 cosine of 45. So we're multiplying all those together. So the d, the distance, would be approximately 202.078 feet using the law of cosines. Now for this next example, we have another bearing, okay, another direction here. So here we have the ship. It's leaving its port from A and goes 40 miles east to point B, and then it changes direction so that it goes 30 miles, and then from that distance, it will be 56 miles away from its point of departure. So what we want to figure out is the bearing from B to C. So if you remember, it's always important to think of bearings in terms of north, south, east, and west. And so I'm just going to draw a line here, this north-south line, and we have the east-west line. So really, we know that this angle is 90. And so if we figure out the angle right here, we can get the bearing. So that means that we're going to look at this obtuse triangle, this oblique triangle, and figure out the angle for B first. So we know that the cosine of B is going to equal 30 squared plus 40 squared minus 56 over 2 times 30 times 40. So B is approximately 105.367 degrees. But remember, we want to take away 90 to get that bearing. So the bearing, when I subtract 90, so let me just write it out here. We're subtracting 90 will be about, I put approximately, but it'll be 15 point, well, that's just 367. So remember, when we give the bearing with north-south, we start with north. Okay, so it's going to be north 15.367 degrees, and it goes to the east. So that will be our bearing in nautical terms. All right, for this last example, we're actually going to look at Heron's area formula. And so there is a very, very good proof. It's a little long, but I'll make a separate video for the proof. But comparing this, so we have a triangle with sides A, B, and C, and we don't know how to find the area without tricks. So we usually draw the height and then use the sine, so 1/2 base times height. But Heron, also known as the hero of Alexandria, he's a Greek mathematician, he discovered and figured out how to find the area without any angles, which is pretty amazing. But use a lot of trig, a lot of Pythagorean theorem. So we're going to find the area given the triangle. And again, if you're given a triangle, always make sure that the sides, you look at the triangle inequality, and it's less than the sum and greater than the difference, just to make sure we have a triangle. Okay, but here we have a triangle. We're first always going to start with S. So S is that value that we're going to be substituting into that square root. All right, so S in this instance will be 5. Let me write this a little bit neater. 5 plus 9 plus 8 over 2, and that's 11. All right, so when we multiply those out, we're going to put this under the area. So the area is going to be 11, and then we essentially take the difference from each side. So 11 minus 5, 11 minus 9, 11 minus 8. And so when we find those out, for here, this will be square root of 11 times 6 times 2 times 3. Okay, trying to look for my calculator here. Okay. All right, square root of 396. So that'll be approximately, I could put 19.9. And we're given the units are in feet, so I'll put feet squared. All right, so I hope this lesson was helpful, and I'll see you all in class.